right, Chapter 22, Conceptual Questions. So first of all, volcanic and other such activity in the mid-Atlantic ridge extrudes material to fill the gap between separating tectonic plates associated with continental drift. The magnetization of rocks is found to reverse in a coordinated manner with distance from the ridge. What does this imply about the Earth's magnetic field, and how could the knowledge of the spreading rate be used to give historical records? So this is a whole branch of geology, where paleogeology, where they're looking for interesting information that they can find out from volcanic eruptions and the rocks that are collected. And so the Earth's magnetic field produces magnetic field lines in that region. So when the molten ferromagnetic material comes out, it has the chance to rearrange itself to match up with the magnetic field, and that can give lots of interesting information. That's number one. Number three, we want to list the ways that magnetic field lines and electric field lines are similar. So electric field lines go from positive to negative. Magnetic field lines go from north to south. There's a similarity. The number of lines is proportional to the strength. That would be another similarity. They differ in a few ways too. Electric field lines, we can just have a positive charge and a bunch of things going away from it. We can't just have an isolated north or south pole. They have to be paired up. With electric field lines, what are they saying here? Also list the ways. For example, electric force is parallel to the field lines, whereas magnetic force on moving charges is perpendicular. Well, that's true. But that's kind of a different concept almost. With electric field lines, we're talking about electrons or charged particles in there. It's the same nature of the beast. We're into magnetic field lines, and then we throw in a charged particle that's going to feel a force that we will describe shortly with the right-hand rule. Number 27, then, there's magnetoencephalograms that are used with the brain's magnetic field. Does the brain's magnetic field imply coordinated or uncoordinated nerve impulses? Explain. Moving charges produce a magnetic field. So if you have moving charges, those moving charges will produce a measurable magnetic field if they're all moving in the same direction. That would be a case of coordinated nerve impulses, those nerve impulses all moving to produce something like charge moving through a wire in a constant direction and that type of thing. So yes, it would.